Hey there, and welcome to another video on SQL for data analytics and data science. And today I would like to walk you through some of the use cases for arrays and window functions in SQL, which I find most common for data analytics. So things that I do and tend to Google quite often when I write SQL queries at work as a data scientist. Again, getting into BigQuery interface, and we will work with the tables that we've worked with previously. We'll start with orders data, so let's refresh what this table has. There are 5 columns. Order ID, it's an integer user ID, also integer timestamp for when the order was created at, price for the order as a numeric decimal, and order status as a string. And let's imagine that we want to know for every user all the orders that they have created, and have these orders be presented in an array ordered by when they were created. So for that, we want to query the orders data table. Let's do that. Let's just see what the output is, and it's 4 rows total in this table. Same user did 4 orders. So we would like to have the ranking of these orders based on their created at date, and after that we want to put the order IDs into a array. Why would we want to do that? Honestly, I don't know. I couldn't come up with an easier, better example, I guess. But let's imagine with a bigger data set, it will be much more challenging. And you, for example, want to actually check that the order IDs are sequential. Then you want to order the orders for every single user within a certain time frame. That becomes a bit more complicated, and this kind of query might be a little bit more useful. So right now we'll look at user ID, order ID, created at, and we want to rank. So we can either use rank function or row number function, and there is a difference between these two functions, and I will tell you what it is in just a second. We want to rank the orders based on the created at timestamp. So here we will add another column which will be created at ranked, cold, for example, and this column will use a rank function and a window function. So rank over, which is a window of data that we take into account when we are ranking our records. The window is defined by partitioning the data based on certain criteria. So we will partition by user ID, because we want it unique for every user ID. We don't want it ranked over all the users, and ordered by created at timestamp, and it's by default ascending, so you need to specify descending if you want it specifically, but I just like to add it so that I know exactly, so it's written there. And here we go. Let's see what we get from that. So our first step, we have a rank, and here we already see that we have 2 orders with the same rank because they were created at the same timestamp. And for example, that doesn't work for us. We don't want to handle ties like this, and instead of rank, if we want everything to be ranked and numbered sequentially, we can use a different function called row number. Yes, exactly this one. And in that case, we have a different ranking. So here we have 1, 2, 3, and 4. Because of reasons. maybe that works better for us, and we definitely need everyone being at a different digit. Now, if we want to create an array out of that, we will wrap this part into a CDE, a common table expression, which we used before and which are super convenient and common to use when you write convoluted long queries using different tables, doing certain different calculations, and it makes it much easier to read the queries. So we will call this CT order sorted. We will remove the limit because we don't need it. And from this order sorted CT, we will select user ID. We will use the function array aggregate, which actually creates the arrays, and we will add their order IDs ordered by row number, or in our case created at rank as order IDs from orders sorted and group by user ID. And now formatting this query. Yes, right. We do need to write as here. Let's see what we get. So for this user ID, we have the order ID sorted, and in our case, since number 3 and number 2 were created at the same timestamp, and when we used the row number, they assigned in a different sequence. So they had a tie and they assigned number 2 row for the order ID 90003 and row number 3 for the ID 90002. So yeah, imagine there is a use case for that. There are use cases for that where I just can't come up with anything that I can easily replicate and create an easy data set to work with for that. On top of the arrays, we can also use other functions. For example, we have here this order IDs array, and we can write a query which calculates how many orders are there. So for that case, we can use array length. Let's see, there are plenty of other functions that you can use. IDs as number orders, and from this query that we will wrap into parentheses, and this will give us, user ID has 4 orders. These won't be a distinct or unique count because it just counts the number of records, and if there is a repeated order ID number, then it will count it double. But it's still a nice function to use when you need to check in how many items an array has if you don't know prior. All right, now we want to move to other table called user events with user IDs, timestamp, name of the event, and the event type. So every time user, clicks on the screen or opens the app, we have the record of them opening app. Let's preview this table. There's a few more records than usual. So user IDs, timestamps, and what they did in our product. And we will use this table to calculate which events come before the current event and which events come after the current event. So this is actually something that's pretty commonly used when you want to see what did the user do after certain action, like when they open the app, what do they do next? Or just before they close the app, what do they do? This is really good for building user funnels and seeing the path of user flows, user experience, pretty commonly used functions, also window functions. So let's query this table. We'll just see that this is what we want. So we need to extract a user ID, event name. Let's skip the event type, and let's take the timestamp so that we know that we are correct. And now we use the function lag on event name to get the previous event, which came before the current event name, which will output first. And we will do this over a certain window, which will be partitioned by user ID, of course. And I guess nothing else. We'll just see for this user everything that happened before this event, and we will order it by timestamp. And again, it's by default ascending, but I like to write it down just for myself as previous event. Yeah, right, underscore. And that's it. So let's see. Yeah, with that much data, it's hard to say. So we will filter out one user and look at that specific user. It's also a pretty common thing when you do data analysis. Just look at one specific user or a different set of users, the different criteria to check out whether the query that you wrote makes sense and actually outputs what you want. So we will order by, order by timestamp again, and let's see the output. Move a little bit. So we have here this user, and ordered by a few different days on which this user were active. We see that first event that we have is app open, and normally there is no previous event, so that's good, it works as it should. The next event is main screen, and we see that the previous event for the main screen is app open. Perfect. And now we want to also see what will be the next event. So for that, we will just copy this line and change the lag function to lead function. So in that case, we will see the next event, looking into the future of sorts. And again, we have event name. The previous event based on the timestamp is app open for the main screen. The main event, for the main event, the next event is order screen, which is correct. So perfect. Now we have this kind of view where for each current event, we know what was the previous event and what will be the next event if there was any. If there wasn't, it will be null. Now let's create a notion of session and check for each session how many events are there, which are those events for every user, and create an array of events in their correct order of sequence based on their timestamp for each session. For this example, I will make an assumption that session is an hour. So for every hour, we will look into what the users did and calculate and add these events into an array. Since we don't need the timestamp anymore, we will use the date function to add here the date. And we will also extract the hour because we need to look at hours for our session definition from the timestamp. It's so hard to talk and write at the same time. Maybe I'm just dyslexic. And as we know, again, we don't need the timestamp, and we actually won't need these as well. As we know from our previous video where we did string manipulations, that event name is actually a little bit wonky in this table, and we don't always have the proper event name. For app opens, we have these problem. Maybe it's some kind of device that does this, for example. That can happen, like different types of devices can have different tracking. So we want to clean it up and fix it, and we want to have a proper app open for the event name when it is app open. So we'll use the case when, and we will check that the event name is containing app open. Then we will extract app open, and else we will have just a regular event name, and we'll end this event name variable. And for this user, we didn't have actually this problem, but let's see which user had the problem, the user number 68. So let's see whether that works. And I think, yes, it does. All event names are nice and clean. Now we will wrap this query into a CTE, common table expression, and we will call it, I don't know, events data. So with events data as this query, we will, actually we don't need to order here because we will fix that up. And let's change it to the other user, so we can check whether the order is correct. And order by is a computation heavy function. So when you have large data sets, when you add this function, add the order by, if it's not necessary for you, just, you know, because you forgot to delete it when you had a filtering on one user, it might cost you and it might add time to the computing process. So be wary when using order. So now we want to select from this, what did we call it, events data. We want to have the user ID, of course, because we want to know sessions per user, per day, and per hour. And now we will create again the array aggregate. So we will aggregate the event name into an array, and we'll order by date and hour. And we'll call it session events. From events data, and we need to group by user ID and date and hour, because I mean, we're kind of shrinking the data. There will be only one record for every user ID, date, and hour, whereas in the previous table there were multiple based on the number of events that happened in that hour. But here we will shrink this data into one row for user ID, date, and hour, and the array will kind of open up, expand into the different number of events. So now we want to be able to group it by date and hour, but we still need timestamp to order by the timestamp so that we know which event came after which. And in our subquery in the CTE, we will only look at this user, and we will get the date, timestamp, to extract hour from timestamp, and user ID. Then we fix the problem with the event name for app open events. And then in our outer query, in the main query, we select user ID, date, and hour, but not the timestamp because we don't need it. And then we create the array of event names, which is ordered by timestamp in ascending order as session events. And when we execute this query, we see that for this user ID, on the day 4th of December, they had 2 events at hour 1. And first one was app open, and then it was main screen. And we can compare it with the raw data just to see whether we were correct. And yes, indeed, I think we were correct. So here we have the 4th of December, and first came app open, and after 5 seconds, milliseconds, seconds, came your main screen. So there you go. There are the usage of window functions and arrays. Those are pretty common. Window functions are very nice to be able to calculate moving averages or cumulative sums or averages over time. It's nice to just browse through the data line by line, look what happened before or after an event. And the arrays are also pretty commonly used when you need to add multiple layers of data in the tracking. So for example, you can have a list of songs that the user listened in this session, and that would be an array of song IDs, unique for a user, and the session ID, and I don't know, the date or something like that. So of course there is so much more that you can learn about window functions and arrays, and it's very often that you kind of go through learning on the job because of the data structuring and different companies is very different. So you'll kind of learn their own little tricks that will work for one place and won't work in another place, and you'll have to relearn things. But these are the ones and the most common ones I found at work. So definitely recommend you check those out. Thank you for watching. Hope this was useful and have a nice day.